The local backend stores TF state as a local terraform TF state file. cdktf supports remote backends. s3backend is supported and will be the one used here. It keeps the state as a given key in a given bucket. Okay, let's see how to use the s3backend construct. Let's get the scope, the bucket, and the key. These are probably required params. There is DynamoDB table for managing the lock of the TF state. Okay. And with that usually comes region. Great. Scope is required, bucket is required too, of course, and the key as expected. Let's check for the DynamoDB requirement. Okay, it is optional, and the region would be optional as well. Great. Okay, let's add a backend. Import the s3backend construct first. Next, we'll need to define the DynamoDB and the bucket. Let's do it in a dedicated stack. A new class, my backend, inherits from the terraform stack. To initialize the class, we can copy dunder init and the super from here. Let's copy that, paste. We'll also use the vars and need the provider, so we can copy those lines too. Get rid of this line, it isn't needed anymore. We'll start with the DynamoDB table. Okay, let's find the DynamoDB table submodule here. DynamoDB table, here it is. What have we got here? The class. Scope and ID are mandatory. Table name. And it usually has attributes. Here we are, which will be set accordingly to meet TF's requirements for locking. Hash key is mandatory to set the primary key on the table. Okay, let's confirm the required params. Okay, scope and ID are required, which isn't surprising. Is there anything else? Scope, ID, name is required too. Makes sense. And these are already the class methods. Okay, great. Now we know how to use the DynamoDB submodule. Let's add the DynamoDB object. But first, a module must be imported. Where is the DynamoDB table? Okay, input DynamoDB table. Next, Dynamo object. Passing self as the scope. And we'll pass a name as the construct ID. Must provide the table name. Followed by the attributes param, which is a dictionary. And the fields are according to HashiCorp's DynamoDB resource example. This one is a string. A table must have a primary key. It is called hash key here. Let's copy this value. I will also add the DynamoDB billing mode. Mode equals to be pay per request. And this is the DynamoDB object. Let's save. Okay, the my back stack is to be added to the app. Now, app is the scope and the ID here. Okay, let's save. Next, check for any syntax errors. No errors. Good. We can continue. Okay, let's define an S3 bucket. Input this submodule from the inputs. S3 bucket. Input S3 bucket. Great. Now an S3 object can be added here. Equals S3 bucket. Let's check the class's definition. Okay, let's explore the S3 bucket submodule. This construct implements this TF module. Let's check it. So here's the resource. And following this example, the S3 resource, all it needs is the bucket name. Okay, going back to the submodule, let's check for the class params. Scope and ID are always there. And the bucket param here. Let's confirm for the required params. Okay, these two are expected, not surprising. And from the TF example, we already know about the mandatory bucket name. Okay, that will do. I pass self as a scope. Give name as an ID. Okay, and set the bucket name. And this is it for the bucket object. There is an interesting note about the changes AWS introduced to security defaults for new S3 buckets. What is stated here is that now public access is blocked by default. However, if we still want to control the public access and not rely on the defaults, we need to use this dedicated resource. Okay, let's check it. Okay, let's check this resource block. Okay, HashiCorp gives us this example. Basically, we have to set to true all these parameters to enable the block public access on a bucket. So this is a construct to block the public access. What has it got? The class, the mandatory pair, specify the bucket for binding, and what is being blocked. This for. Fine, let's do that. Okay, let's input the S3 bucket public access block from inputs. S3 bucket public input S3 public block. Great. Now let's create the class instance here. The class self as the scope. Give it a name to be the construct ID. Okay. Now pass the bucket to associate. self backend s3.id to pass its name. Next is to set each of the blocking params to true. This is HashiCorp's syntax. Might be a good reason for defining a private bucket custom construct in the future. Ignore, set to true. Okay, the block public access resource is defined. Let's save. Now let's check for syntax errors. No errors, great. Let's try to deploy all stacks with the cdktf deploy. It worked. Great. Okay, now we can try to add the S3 backend here. The scope, pass the bucket's name, and the key param, which is the tf state file. Okay, the Dynamo table. This one to manage the state locking. And the backends region. Okay, let's save it and check for errors. cdktf synth. No errors. Now we can try to deploy the project-wide stack. Okay, the backend configuration changed error. Need to migrate this state. Interestingly, it says terraform here and not cdktf. So the config files is in this directory under /stacks, my stack, and this is the JSON file. For the migration to work, we need to switch to that directory. Now we can try to execute terraform init, migrate /state, and see what happens. Do you want to copy the existing state to the new backend? Yes, I do. The pre-existing state is local. There is no state in the newly configured S3 backend, of course. So we are copying this state. And here we go. The state is migrated. Let's switch back and try to deploy the project-Y stack. cdktf deploy project-y. It worked. Great. Okay, we can change the state setting for the my backend stack by copying these lines. Add them here and change the project y, change the key to this stack name. There are two independent states, one per each stack. Save it and check for syntax errors. Of course, we'll have to migrate these stack states. Let's see. Yeah, same migration exercise. cdktf out states my backend. and to search for the migrate. Okay, same warnings. It is my intention to copy this state to the new backend. Great. Okay, let's switch back to the project dir. And now we can try to deploy the my backend stack. Great, it worked.